The last section when we talked about radicals, the radicals we treated very similar to what we do with rational numbers, which is what we're going to look at next, for rational polynomials. In the sense that we don't want a denominator that has a square root. So the other thing that we can't ever have is a denominator that has a 0 on it, right? So we're going to look at rational expressions today, and basically it's simplifying, multiplying and dividing, adding and subtracting. Now, so the rational expressions. Let's look at an example here. What we're going to look at basically today and tomorrow. What does that equal?
6 over 20.
6 over 10? 20. Sure. Now reduce it. Is it? 3 over 10, right? Okay. Here's the situation though. If I have this, okay, multiply those now.
X squared.
X squared. X squared plus 2x.
Yeah, now reduce it. I can, but reduce it.
But the
Could be
The bar?
x plus 2.
What is it?
X plus 2.
X plus 2.
What? No.
No, I'm doing
I
something
think it's
completely
different.
different.
X squared divided by x squared.
That would be like
No,
subtract.
Yeah.
No?
No, this.
I think
Five.
can't you divide them?
No.
That's what I'm asking. I want to reduce it. It's a
you
fraction.
can put the x multiply x squared plus 5x plus 6 over.
Yeah.
No?
Okay, so here's the problem that you have. All right? I've asked you 2 questions. You've done them the exact same way. Neither one is incorrect. But you went about it in a process that took you to something more complicated than you need to. So now watch. Let's do this one again, and then you figure out what's going to happen
Now
next.
choose x.
There's the easy way to do it. Now, knowing what I just did there with that fraction, do the same thing with the rational function, the rational expression.
Be x plus 4 over x plus 3.
There, it was reduced.
How can we do it? It's just done.
Look at 3.
Plus 3.
X plus 3, sorry, thank you. How can I do it? Because I'm multiplying these, the same way I multiply these. I'm multiplying and dividing. I didn't have an add in there. I don't have an add in here,
But
Right.
x
But you have in the brackets.
in the brackets, but I can cancel what's out in the brackets. The same way I can cancel a 2 with a 4, even though they're not in the same fraction. I divide this by 2, I divide this by 2. I divide this fraction by x plus 2, and this one by x plus 2, right? These two cancel, they're the same thing. Okay, so let's do it like this then. Okay, you don't like what I do? Then watch this. Okay, this is x plus 4 times x plus 2, right? Over x plus 4, x plus 2. Or sorry, x plus 3, correct? Right? What's x plus 2 divided by x plus 2?
1.
Why can't I cancel that? Right? Okay? Make this simple for yourself. All right, so you understand what I'm doing with this, right? So far?
Yeah.
Okay? That's it. Now, there is one thing. So this is a simplified expression that I asked you to do. We're going to get quadratic equations, factor them, and make them simplified. But I still have, again, I have to identify, just like you did in the last section, I have to identify the restrictions on it. So the very first thing I do with this is I find the restrictions first before I do anything. What can x not equal in this?
I find 0.
Pardon me?
This case, x must define -3. Just.
-3
And
and -2.
yes.
Do the restrictions, okay, right away. Now, so, this is what we're looking at. We're working with rational expressions. It's not complicated. It's a whole pile of factoring. All right? We did a whole section on factoring. That's what we got to do right now. Yeah.
For the top one, if you did it the other way, couldn't you reduce 6 out of 10?
Yeah, 6 out of 20. 6 over 20.
Oh, I put the wrong number there.
Right.
Okay,
And I do. So then I reduce it to 3 over 10. You're right. But my point was, I want to make this simpler. I want to do the math as easy as possible. So if I cancel first, then multiply, I've got it in lowest terms right at the end. Go ahead. Ready?
Those numbers sometimes.
These numbers?
Yeah.
Looking at this right now, I have 2 fractions.
Yeah.
I can't have a 0 on the bottom of either of these 2 fractions.
Yeah.
So what can x not equal here so that it doesn't equal 0? X plus 2 can't equal 0, x plus 3 can't equal 0. X can't equal -3 and -2. So I'm going to come back to this.
No,
Okay.
that's fine.
But I just wanted to show you. Okay, so this is the start of it. So again, it's little math tricks that we do. Okay, so now take a look at page 230, and you're going to do this yourself now. All right? Or with me, whatever. Okay, the first thing they want you to do is identify the restriction. So, in order to identify the restriction, I'm looking for the numerical value that x cannot equal, because if it does equal, I'm going to end up with 0 on the bottom. So to identify restrictions, I take anything in the denominator, I let it equal to 0. I'll put that through there. I like that. Okay, then I understand that x can't equal that. And now I'm going to solve for x to find out what value x can't equal. So in this case, x can equal, I add 3, divide by 2. So x can equal 3 over 2. Right? And then that's it. That's all they're asking for in that first one. So-
How did you do that?
Sorry?
Sorry, how did you do that?
Okay, look in your book right now. Page 230. See where it says 2x subtract 3?
Yeah.
How do I move the 3 to the other side?
Oh, that's from
So write it in there. 2x equals 3. What does x equal? 3 over 2. Therefore, the non-permissible value of x is 3 over 2. Write this as x cannot equal 3 over 2. Okay, your book's good. All right, so what about the next one then? 1 over x squared minus 5x plus 6. Okay, so we identify that the denominator cannot equal 0, right? So they say to start like that, okay? So how do I solve any of these quadratics to find for x now? We know 4 ways. What's the simplest way?
X equal to
Relax. What is it? Factor. If we can factor, right?
yes.
What are the other 3 ways? Graphing, quadratic formula, or completing the square, right? So we're going to stick to factoring for this whole thing. This is why we work so hard at it in grade 10. Okay, so let's factor it. What are the factors of x squared?
You get 3.
What are the factors? You gotta listen, buddy. What are the factors of x squared? So let's start there. Okay, now what are the factors of plus 6 that add to give you -5? Now you got it. -2, -3. So x can't equal,
2 and 3.
that's right, that's better than this. X can't equal 2 and 3. Okay? What's that? Okay? So looking in your book right now, the denominator is x squared minus 5x plus 6. Determine the roots, the zeros of the quadratic expression. So that's x minus 2, x minus 3. X minus 2 equals 0, x minus 3 equals 0, x is equal to 2, x is equal to 3. The non-permissible values are 2 and 3. Write this as x can't equal 2, x can't equal 3. Okay? So they show you how to do it in your workbook. All of the steps. It's the first example. All right? Okay. Again, follow along in your book now. X squared minus 9x plus 14 over x squared minus 25. Okay? So we are only dealing with all the question asks right now. This is the start of it. This is what you have to do every single question from here on in the whole section. Okay? Find my non-permissible value. So, what's my denominator in this question? Okay, so x squared minus 25 equals 0, right? Okay? How do I solve for x here?
X plus 25.
Just wait. Just wait. What did you say? Sure. And then square root it, so then what's my answer? X can't equal?
Plus minus 1.
Cool. First of all, there's that. Right? So you only got one of them. Okay? Not a fan of this. It worked. It works every time. I'm not a fan of it. Because right now Nicole would have got only half of them. Okay, because she forgot that the square root is plus minus. Okay, and that's fine.
Square root first.
No. Here's the problem I have. Look at x squared minus 25. What is that? What is it? It's difference of squares, isn't it? What does difference of squares give me? X minus 5, x plus 5 equals 0. Alright? We just hammered this home with grade 10s today. This is exactly what we're doing in grade 10. You have to recognize this. Okay? And it gets more important as you get to grade 12. You've got to recognize that. So what is the answer? X can't equal 5, x can't equal negative 5. Right? So, Nicole, you see that? Alright, so doing it your way was fine. I have 0 problems with you doing it your way, but you got to make sure that when you take the square root that you use the plus minus. Right? There's why. Okay?
So
There it is.
the way she said works too?
Yeah.
You just have to put them.
But you got to make sure that you have the plus minus. Yeah. I just want you to recognize that. Okay? All right. Let's look at 2 is still state the non-permissibles. The only one I want to look at is 2c. What's the denominator in 2c? Oh, actually, it asked me to simplify. Let's do the whole thing in 2c. 2x squared minus 4x minus 30x. Awesome. Minus, is it 4x?
4x squared.
It's 2x cubed.
2x cubed? Okay, thanks. 2x cubed minus 4x squared minus 30x?
Yeah.
And that's over
4x squared. Subtract 20x.
subtract 20x?
Yeah.
No, it's just 21.
20.
No, it's 20x.
Oh, which is it?
20x.
Mine doesn't have
Oh,
minutes.
it's
No,
not.
it's 20.
4x.
2c. On the backside. Oh, the backside it has an X, that's why.
Okay, well, let's look
Oh,
at
are
the
you looking at?
question.
What?
It's the same.
Yeah.
Oh.
It should be, you know what? Okay, hold on a second here. Everybody just relax. I think it's a misprint on the front. Okay? It should be that. Okay? It should be that, and I'll show you why in a second. Okay, so start every single question from here on in. Whether you're multiplying and dividing, all right, or just simplifying as we're doing today, find your non-permissibles first. So what's the denominator?
Where's
4x squared minus 20x equals 0, right? Okay? So, I need to get this into the zero product rule. How do I factor that? Well, I got two terms. What's the first thing that you're supposed to do every time you factor? Take out the greatest common factor. Is there a greatest common factor there? What is it? 4x. Yes, it is. 4x. Which leaves me with x minus 5 equals 0.
You got
Okay? 4 goes into 20. X squared, or x goes into x squared. So we've got a major factor there, right? So what can x not equal then as a part of this? What can x not equal?
5
5? Is that it?
and 0.
And 0. Also very important. Why is that? If I put 0 in here, what's 0 times 4? It's 0, right? What's 0 times negative 5? Still 0. Don't forget. Don't forget.
But I make it.
But why did you put the five?
Something for
Okay, if I put 5 in here, what's 5 subtract 5? 0 times 20, it's still 0, right? Okay, everybody's okay? I'm trying to go through this. I got to go through it quick, but at the same time, I don't want to lose you. All right, now it says to simplify this expression top and bottom. First thing that you need to know at this point right here, do not cross anything up. Don't. You must simplify the top, simplify the bottom into its parts, and then cross things out. You cannot cross out a square, this 4x squared, this 4x squared. Don't do it. Somebody's going to try it. I guarantee it today. Somebody will try it. Don't do it. Okay? So, let's break this down. What's the very first thing I look for? Greatest common factor. What's the greatest common factor in the top shelf? 2x. So let's take a 2x out. 2x. That leaves me with x squared minus 2x minus 15 over my bottom 4x times x minus 5, right? Okay? Can we factor x squared minus 2x minus 15? Is it possible to factor it? Are there factors of negative 15 that add to give me negative 2?
Yes.
What is it?
3, 5.
Okay?
With one of them being negative.
Yeah, which one? Which one's going to be the negative?
X.
Negative 5.
X has the difference and.
Okay, so it's 2x, x minus 5, x plus 3, over 4x, x minus 5. Now I look at this right now. I have a fraction that has terms I can cross off. So what's the first thing that you want to cross off here?
2 and 4.
Sure. Okay, and what will that leave me with?
It will be like this one.
Leaves me with a 2 down there, right? 2 over 4 is a half, correct?
Yes.
So that's a half, okay. What else can I cross off? X and X, let's start with that. Those cross off. That leaves me with 1. And what's the next thing I want to cross off?
minus 5.
X minus 5, X minus 5. So what am I left with? X plus 3 on top over 2. Here's the simplified expression.
Okay, I have a question.
Go ahead.
So the top we divided by x squared, and the bottom, does it have to be the same, or you could divide by 4, or whatever goes into them?
Okay, ask your question one more time. I didn't follow it. Try again.
So the top one,
Yeah,
you divided everything by 2x, or took the
I
2x,
factored a 2x out here because 2x goes into all three
but
of
you
those.
don't have to do the same number in the bottom?
No,
you could
I can
change
do
it?
whatever I want. Yeah. Okay, that's a good question. All right. Any other questions?
Can you just divide all the top by 2? And like,
Yeah.
now we're to x, we just.
If I divide all the top by 2, I'd be left with x cubed, 2x squared, and x, and it would be hard to factor still. I have to take the 2x out. You have to take the greatest common factor out. In this case, the 2x is the greatest common factor. Okay? Question?
When you took the 2 and the 4, and then you did x and x, because you just take the 2x.
You're right. Okay? All right. Now, look at page 233. Okay. So first thing I do when I do these questions is what? No. What? Before that. What do you say? Non-permissible first. Okay. So what's my denominator?
9 minus x.
Right. 9 minus x equals 0. Add x. Too far. It can't equal 9, right? So now, Laura, what do I do? Now I do my greatest common factor. So there's nothing that comes out of the top to the bottom. Okay? So factor the top for me. Difference of squares. So what does it factor to? Okay, and then the bottom is nothing, right? Okay, so I have that. Okay? Can I cancel? Anything to cancel there? Anything exactly the same on the top as is the bottom?
X minus 9 will be a different value than 9 minus x.
Okay, so I can't cancel anything?
You can take a -1 and then -x.
Ty, you're ahead of your game here. What do you got?
You can take the -1 out of the 9 minus x.
And what will that change it to?
-1 x minus 9.
Okay, so Ty's a little bit ahead of the game here, but he's absolutely right. All right, my goal is to simplify the expression as best I can. So I will manipulate it so that I can simplify it, right? If I take a -1 out of this bracket here, what does that change it to? Changes both signs, right? That to a negative, that to a positive. Correct? Okay?
But how can you do it like just in the bottom part? Don't you have to do it on the top?
No. No, I don't. I only have to do it to 1. From the top to the bottom. It's no different than taking a 2 out of the x out of the top and a 4x out of the bottom here.
So then
I
you're
don't have to do it because I'm not changing it, right? If I multiply, just a second, Gavin. If I multiply this back in, what am I going to end up with? 9 minus x. So I'm not changing the question. I'm just making it so it's better for me to simplify. Follow? So now, that crosses out. What am I left with? Yeah. So -1 times x plus 9. And you leave it at that. Or you could leave it as x plus 9 over -1. It doesn't matter. Remember, it doesn't matter if the negative's on the bottom or it's on the top. Right? Okay, it's the same thing. -3 over 4 is the same as 3 over -4. All right. This guy right here, this is similar to what we did with the radicals. The additive inverse, that's what that is. Just changing it to its additive inverse. Okay? This one's a little different than that, but it works the same way. Okay? Now, flip through to page 242. Okay? So all of this is just simplifying so far. Now, those are singular fractions that I'm simplifying. The whole first section, 5.1, is on simplifying singular fractions, okay? That's it. All right?